A chili pepper does something almost ridiculous. It sets your mouth on fire, then lets a bird eat it like nothing happened. Same fruit, same molecule, two completely different reactions. So why does a chili pepper punish mammals but spare birds? First, the pepper is not actually hot. Its temperature has not changed. What changes is your nervous system. Inside your mouth are sensory nerves with tiny molecular gates. One of those gates is called TRPV1. Its normal job is to help detect dangerous heat, like a sip of tea that is too hot or a surface that might burn you. Now imagine TRPV1 as a fire alarm. Real heat can press the alarm. But capsaicin, the spicy molecule in chili peppers, has a fake key. It opens the same alarm system even when there is no real fire. The accurate version is this. Capsaicin activates TRPV1 ion channels in mammalian sensory neurons. Once those channels open, the nerve sends signals that the brain interprets as burning heat and pain. That is why a chili feels hot. But here comes the twist. Birds have a different lock. Birds have related heat-sensing machinery, but their version of TRPV1 is much less sensitive to capsaicin. So the pepper's fake key does not open the bird's alarm in the same way. To a mammal, the pepper is a warning sign. To a bird, it is lunch. Now the question becomes bigger. Why would a fruit do this? Fruits usually want to be eaten. A cherry, a berry, a fig, a pepper. The bright color is often an advertisement. Eat this fruit, carry the seeds away, and leave them somewhere new. But not every eater is equally helpful. A bird often swallows a small fruit whole. The seeds pass through its gut and can be dropped far away in a little packet of fertilizer. A mammal may do something very different. Many mammals chew with molars. Those teeth are good for crushing food, but they can also crush seeds. For the pepper plant, that is a disaster. A seed that gets ground into paste is not a future pepper plant. So capsaicin works like a selective bouncer at the door. It does not keep everyone out. It keeps out many of the animals that are bad for the seeds, while letting in animals that can carry the seeds away. This is called directed deterrence. The pepper is not defending itself from all eaters. It is discouraging the wrong eaters. But be careful with the wording. The pepper is not thinking, "I prefer birds." Plants do not plan like that. The accurate version is natural selection. In wild peppers, fruits with chemicals that discourage seed-destroying mammals while still allowing bird dispersal could leave more surviving offspring. Over many generations, that chemical filter could spread, and the filter is placed almost perfectly. Many people think the seeds are the hottest part of a pepper, but the seeds themselves do not make capsaicin. Much of the heat is concentrated in the pale inner tissue around the seeds, called the placenta, and in membranes inside the fruit. That is like putting the security system right next to the treasure. The treasure is not the fruit flesh. The treasure is the seeds. But there is another layer. Capsaicin may not only be about mammals. Some studies suggest it can also help protect wild chilies from fungi that reduce seed survival. Other research suggests hotness can carry costs, such as effects on water use or seed production under certain conditions. So the full answer is not one simple sentence. Capsaicin is part pain weapon, part seed defense system, part ecological filter. And then humans show up. Humans are mammals. We should be on the keep away list. Yet many of us learn to enjoy chili heat. We turn to plant defense into salsa, curry, hot sauce, and a global challenge sport. In a way, we are the pepper's weirdest accident, the mammal that farms the pain. So why do chili peppers hurt mammals but spare birds? Because capsaicin tricks mammal heat sensors into screaming danger, while birds are much less sensitive to that trick. And in the wild, that difference matters. Mammals often destroy seeds. Birds can spread them. The pepper is not really burning. It is sorting its visitors. And every time a bird eats a chili without flinching, it is carrying away the answer.